So next we're going to sort of bridge the gap between the greatest common factor and another technique called grouping. Okay, and then we'll talk about this grouping idea. It's another technique for factoring. And so to bridge the gap, we'll look at kind of a complicated GCF problem. Okay, so if I had something like 2 times the quantity x plus 5 plus x times the quantity x plus 5. Well, notice in this expression I actually have two binomials. They happen to be the same. And I also have two monomials, but they're linked by an addition. And so really what I have are two really big terms. Okay, one term is here on the left, 2 times the quantity x plus 5. The other term is here on the right, it's x times the quantity x plus 5. And so these two terms are bigger, but they each have a common factor. Together they have a common factor, and it's the x plus 5. So notice that they each have two factors to begin with, 2 and x plus 5 on this first term, and x and x plus 5 on the second term. And so x plus 5 is common, and so you can actually factor out a common factor that's a binomial. So I have x plus 5 as the factored out factor, and then the remaining factors are 2 and x. Okay, and so this gives me actually a binomial, a pair of binomials as the factors. Okay, it's kind of interesting. It's a little bit weird, but it works because we're just factoring out a binomial common factor. Okay, but now think about this for just a moment. Let's look at what happens if I were to distribute these, the x and the 2. Here I would have 2x plus 10, and over here I would have x squared plus 5x. Right, so I actually have 4 terms there. Now technically I could combine some like terms, but I'm just going to leave it as 4 for just a moment, because I think it's going to be important to see something here. When we get into this idea of grouping, we're going to be looking at polynomials with 4 terms. Okay, and then what's interesting about this is when you have these 4 terms, the first 2 have a common factor of 2, and the last 2 have a common factor of x. And so you could actually factor out the 2 and factor out the x to get here, and then pull out the greatest common factor, which is a binomial, to get here to the factored form. And so this now gives us a process. If I were to give you 4 terms, you could actually go to this step, which factors out 2 GCFs from 2 sets of terms, and then goes to this final factored form where you have the binomial common factor pulled out and then another binomial left inside. Okay? Let me show you how this works when doing, we'll call this grouping. Okay, it's called grouping because we're grouping the first 2 terms together and the last 2 terms together and factoring individually out of them, and then pulling the big binomial out as long as it's common to both terms. So let me show you an example, kind of working that all the way from the beginning. Okay, so if I were to give you 4 terms, a polynomial of 4 terms, something like 5 x squared plus 10x, actually let's make it an x cubed and an x squared, and then let's go with a plus 2x plus 4. Yeah, that should work. Okay, so on this one I'm going to attempt the grouping. Notice again I have 4 terms. This time I actually could not combine like terms, but I wouldn't want to if I was using grouping anyway because I need 4 terms. So here I have 4 terms, and I'm going to try grouping the first 2 and grouping the last 2 and pulling a greatest common factor out of them individually or as 2 sets, and then see if I can go on from there. So out of this first set, I notice that there's a 5 in common and an x squared, so I'll pull those out. 5x squared, that's the GCF. The remaining factors are x and 2, okay, when I divide those out. In the second pair, they have a greatest common factor of 2. I still am adding, so I should bring down my plus. I can pull out the common factor of 2, and the remaining factors would be x and another 2. Right, so it would be x plus 2 when I divide both by 2. Now notice I have a common binomial. It's x plus 2. And as long as that binomial is the same in each term, I could factor it out as a greatest common factor and then leave in parentheses the remaining factors after they're pulled out. So if I pull out the x plus 2 from the first term, I still have 5x squared. And if I pull out the x plus 2 from the second term, I'm still left with a 2, a plus 2. Okay? And so you can see we end up with 2 binomials multiplied together, which makes it a factored polynomial. Okay? Interestingly, if you were to check and make sure it works, you could just redistribute everything back in, and you'll end up with the 4 terms that we started out with. Okay? Let's try this again. Some of these grouping problems will mix multiple variables in them. Some of them will have some tricks with the negative signs in them. So let's take a look at just a couple more examples before we move on. So let's try something like xy plus 6x minus 3y minus 18. Okay. So in this one, I again have 4 terms, and I'm going to group together the first 2 and the last 2. Okay, so I'm grouping these 2 together, grouping these 2 together, and I'm going to pull out whatever the common factors are, the greatest common factors. And so in these first 2 terms, they share a common x, so I'll pull the x out. I'll be left with a y and a 6, so that's y plus 6. And out of the last 2 terms, they definitely share a 3. They also have a common negative. Now you can pull out a negative or factor out a negative, whether it's common or not. You just have to make sure to change all the signs in the parentheses that you pulled it out from. Okay? So here, if I pull out a minus 3, I've just got to remember to change all the signs on the inside. So the originally negative 3y becomes a positive y. And the originally negative 18 will become a positive 6 because the negative came out. Again, you can always check your work, or even just mentally check by thinking negative 3 times y is negative 3y, and negative 3 times 6 is negative 18. So if you redistribute, you can check to make sure it works. But now, notice I have a y plus 6 and a y plus 6, same binomial factor. If you don't have the same binomial factor here, you've either done something wrong or the polynomial doesn't factor, okay? So you need to have the same binomial factor here. If it's a common factor, I can pull it out. So I get y plus 6. And then the remaining factors would be x and minus 3. So I'd have x minus 3 left. Okay? Okay. Next example. Let's throw some more negatives and maybe a few extra variables. So let's make this one a little bit more complicated. Let's do cx minus dy. Oh no, make that a dx, sorry, dx. And then we'll do a minus dy plus cy? Yeah, cy at the end. Let's see what happens here. In this first pair, this first set, they have a common x. So I'll pull the x out. I'm going to be left with a c minus d in the parentheses. I'm just trying to think ahead and see what's going to happen. In the second set, I have a common factor of y. So I could pull out the y. Now, I have an option here. I have a choice to make. I can either pull out a positive y or a negative y. Notice I have a minus and a positive in the next two terms. And so what I want to do is pull out a y, a negative or positive. I want to pull out the sign that makes the two leftover factors match what I have before. Here I have a positive c and a negative d. Positive c with a negative d. My signs are consistent with the previous binomial. So I'm actually going to pull out a positive y because I don't want to change any of the signs. If I pull out a negative y, then I have to change those signs. So I'll pull out a positive y, or plus y, but then I have to keep all my signs the same. So this next term is still negative d. I have to have the negative on that. This will become a plus c, right? Because positive y, negative d makes negative dy. Positive y and positive c make a positive cy. So I have to keep the signs in such a way that they're the same as the initial polynomial because I pulled out a plus. Now, these two expressions don't right away look the same, but because we're adding, we can commutative property, we can commute the two terms, and this actually is the same as c, it would be c plus negative d if I commuted them, but you know c plus negative d is the same as c minus d, so I'll just write that as c minus d. Negative d plus c and c minus d are actually equivalent to each other. Okay, now I'll finish off writing all the rest of this. Okay, and so now I have my least common denominator is a binomial. It's not least common denominator, get that confused. Greatest common factor. Now my greatest common factor is this binomial, c minus d. So I'm going to pull that out. And I'm going to be left with x plus y in the parentheses. Okay. Again, now I have it in factored form. And there's not really anything else I could do, except if I wanted to check my work, I could always do that. Again, I'm not going to write it up, but you guys could do this, and I do advise that, at least for a while till you get the hang of these, is to go ahead and redistribute all these and see if you get the same answer you had at the beginning, right? C times x is cx, c times y is cy. Negative d times x is negative dx, and negative d times y is negative dy. So it works. But I think that's a good way to go about checking your work to make sure it works. Okay. Now there is a rare case where you may have to rearrange some of these terms in order to make the binomials work out, okay? So it doesn't always work out. You can't always factor these in the order given, so you may have to play around with the order of the terms and which ones you're grouping together to make it work. It's pretty rare that you would have to do that, but if you're working on the factoring and you can't get these binomials to be the same, it may be the case that you have to rearrange the terms a little bit and try again and see if that helps, okay?